Welcome everyone, ladies and gentlemen. Welcome to the COGEN Europe offices here in Brussels, and also good afternoon and good morning and even good evening to all of our online participants. We have around 150 to 200 people joining around the world, including Asia and North and South America. So welcome to this study launch event entitled Highly Efficient Energy Hybrids, How Cogeneration Drives Flexibility, Resilience and Decarbonisation. So my name is Hans Korteweg. If you don't know, if we haven't met yet, I'm sorry. And I'm the Managing Director at COGEN Europe, and I will be your Masters of Ceremonies for this afternoon. So once again, welcome, and we're very excited. The COGEN Europe Secretariat have been working diligently for, I think, over a year now with Compass Lexecon to bring the study to fruition. And we're very happy and excited to share those results. Maybe just a few housekeeping points, especially for those of you that are participating online. There is a Q&A function, and I have an iPad here, and I'll be following the questions. So there'll be 3 opportunities to ask questions, either in the room itself or via the Q&A function via the Zoom platform. So don't be shy and do put forward your questions. It may be that we cannot get to all your questions, but we will have them and we will try to get back to you offline. Obviously, the webinar is being recorded, and we'll make that available in the coming week or so, as well as the full study results. They should be ready in the next, say, maximum 10 days, 2 weeks. We need to finalize graphics and formatting and...
Recording in progress.
Oops. From now. What else did I want to say? Yeah, that's about it. So I'm very pleased now to really invite Marco Pesaglia, our chair of COGEN Europe, who will do the formal welcome and introduction. So the floor is yours, Marco.
Thank you, Hans, and good afternoon, everyone. It's my very great pleasure to welcome you today on behalf of COGEN Europe, and to thank you all for joining us for the launch of this important new study on the future of the role of cogeneration in Europe's energy transition. I would like to extend a special welcome to our members, partners, policymakers, industry representatives, and all stakeholders who are joining us today, both in person or connected and online. Your presence here today reflects the growing recognition that Europe's decarbonisation journey is entering a new and more complex phase. One phase in which competitiveness, resilience and affordability must advance together with climate ambition. For many years, Europe's energy debate has rightly focused on the need to reduce emissions and accelerate the deployment of renewable energy. But today, the challenge is broader. We must also ensure that our energy system remains reliable, flexible, and cost-effective, while supporting industrial activity, district heating networks, and local communities across all over Europe. This is precisely why we commissioned this study. So, COGEN Europe asked Compass Lexecon, one of the Europe's leading energy economics consultancies, to examine a simple but crucial question. What role can cogeneration play in an increasingly electrified and renewable-based energy system? And how can cogeneration work alongside with heat pumps, electric boilers, thermal storage, solar energy, and other clean technologies to deliver practical decarbonization solutions for industry and for heatings? The results that we are going to see today are both timely and encouraging. Across 5 real-world industrial and district heating case studies in different European countries, the analysis shows that cogeneration remains highly relevant, not as a standalone solution as in the past, but as part of the hybrid system of the future. The study demonstrates that when CHP is integrated with electrification and renewable technologies, it can help lower overall system costs. It can help improve operational flexibility, reduce emissions, and relieve pressure on electricity grids. The finding also reminds us that something essential about the energy transition will not be delivered by one single technology. It will be delivered through intelligent combinations of technologies, combining renewable generation, electrification, storage, digitalization, and of course, highly efficiency cogeneration. That means that policy framework must evolve accordingly to these findings. And Europe needs a regulation that rewards efficiency, values flexibility, recognizes system benefits, and supports investment in pragmatic decarbonization pathways. We need a technology-neutral approach focused on outcomes and not on targets on single technology. Lower emissions, lower costs, stronger resilience, and faster implementation. Ladies and gentlemen, today's study is not only about cogeneration. It is about how Europe can succeed in building an energy system that is decarbonized, competitive, and secure. And it is about ensuring that climate ambition goes hand in hand with economic strength. And it is about making the transition workable for business, households, and communities across Europe. So to conclude, I would like to thank, of course, Compass Lexecon for their rigorous analysis and close cooperation throughout this project. And I would also like to thank all COGEN Europe members who contributed expertise and case study inputs. I must personally thank also Hans and Alexandra for having followed this study, and all the team for having organized the study, and for today's event, for having organized today's event, and for organizing all that will follow this event. Today is the starting point of our study. We see it like this. And before I close, I would also like to express our sincere appreciation to the sponsors of the study. Their support, engagement, and commitment have helped make this work possible, of course. We are grateful for their contribution and for their continued dedication to advancing efficient, resilient, and sustainable energy solutions across Europe. As shown on the screen, please join me in talking in thanking all our study sponsors. And to conclude, really, I hope today's discussion will help inform policymakers and stakeholders as they shape the next phase of Europe's energy agenda. Thank you once again for joining us, and I wish you an insightful and productive event. Thank you.
Okay. So thank you very much, and let me continue where Marco ended. So first of all, thank you for Hans and Marco for the introduction. Thank you for COGEN Europe for commissioning the study with us, and also thank you for inviting us to present the study today. I will give you 20 minutes, 25 minutes intro to some key results of the study, and I will start with a bit of a scene setter. Yes, perfect. With setting the scene, basically, what is the background of the study? Oh, I need to click myself, sorry. So I will cover first a bit of a background to the study, like the introduction was the background, and then go into some of the key results, not covering everything that is in the study. As already outlined, the study will be published. It has a relatively comprehensive modeling appendix with like a lot of results, which is impossible to present during a meeting like this. So we'll focus on some key results today. In terms of background to the study, we were asked to analyze basically what is the role of cogeneration within the evolving European energy system in the framework, with the targets that were already outlined by the previous speakers, like the ongoing idea to reduce emissions going forward, with a framework condition that's increasingly shaped by the question of affordability and competitiveness, and also the ongoing, not yet completed transition of the energy system as a whole within these framework conditions. Industrial end users and district heating operators need to continue doing their business, and the question here is for them, of course, how to do this in a competitive and affordable way. And therefore the question is, what is the role of cogeneration here to provide efficient decarbonisation, cost-efficient decarbonisation, and what can be a wider system impact? And that's something that we have covered in the study by an approach that was specified by COGEN to look into very specific, very detailed case studies comparing applications of cogeneration technology with alternative setups. And what we've done here is define, together with COGEN, 5 use cases of cogeneration technologies and specify what is called hybridized setups. Hybridized setups means that's not only just one technology, and that's something that Marco highlighted already in his introduction statement. It's not just one technology, but it's a bundle of technologies that are used by the end users or by the district heating operators. So in the hybrid setups that include CHP technologies, we have like the CHP together with like electrified technologies, together with like backup boilers, together with like storage is very important to provide some flexibility. And we compare in those use cases these setups against like, again, hybridized setups that do not include a CHP technology. So where we basically need to meet the same demands, electricity demand, heat demand, steam demand, in one case cooling demand, by a setup of technologies that do not have a CHP available, so therefore need a different setup of technology. So this could be gas boilers that gradually use green gas, power to heat technologies being either direct electric boilers or heat pumps, and again, of course, heat storages to provide flexibility. And so we have defined, and I will go a bit into the definition of those use cases later on. We have defined like hybridized CHP setups and hybridized non-CHP setups and compare those two. And how do we compare them? So we have basically specified 5 dimensions that are interesting for this comparison. We've looked into showcasing how there's like complementarity between the usage of these technologies with like the electrification and renewable technologies. We've looked into the use of fuel and energy efficiency questions. We've looked into how these setups contribute to the decarbonisation target. We've looked into how these setups contribute to the question of competitiveness and affordability. And finally, we've looked into the wider system impact, to what extent the setups can contribute to providing system services that are increasingly needed in a decarbonized electricity system. I'm not going into full detail of this, maybe just to highlight a few things on the modeling approach. So what we have done, we have specified together with COGEN those 5 setups in the non-CHP and CHP configuration. We've looked into like two dimensions. So one on a long-term basis, on a structural basis, what is like an efficient and cost-minimizing structural setup of these bundles of technologies. So how to size them, how to combine them, and how to integrate them together in like a portfolio of technologies. And then on a short-term basis, basically to dispatch them in a way that considers all the operational restrictions and conditions and framework conditions that are around, and get like a cost minimal production of cost minimal meeting of demands of the end users of the district heating systems. And that was to some extent an iterative process. So when you dispatch those installations, you find out that there's like probably a more optimal way of sizing them. And at the end, we came up with like setups that were like leading to low total cost while being dispatched in a cost optimal way over the course of a year. So we did like a yearly modeling for each hour of the year, but we also modeled like the full horizon until 2040. So it's not just a perspective of looking into what is happening today, but also looking ahead what is happening in 2040 with like a transitioning energy system that changes, of course. We have like in all countries an increased deployment of renewables. We have in all countries changes in the generation of those technologies and leading to different prices over time. So the structure of the electricity prices is evolving over time, and that's something that's considered here. And we've also considered scenarios for energy price and also gas price and carbon price that is basically impacting these this modeling. So it's not a static modeling, but it's like a relatively fine, granular, hourly modeling up until 2014. We have done this for 5 use cases, and all these use cases are in different European countries. So we've looked into an industrial application in Spain. We've looked in another industrial application in Italy. We've looked in 2 district heating systems, one in Poland, one in Romania, and we've looked into a pulp and paper use case in Germany. By choosing those use cases, we have on the one hand covered both dimensions, the question of how can CHP contribute to district heating and how can CHP contribute to industrial energy use. And we have also covered like the different and diverse status of energy systems that we have in Europe at the moment. So we have like very renewable heavy energy systems like the Spanish one, and we have on the other hand like systems that are still have a large part of the transition ahead of them when looking, for example, into the Polish or the Romanian system. And we also have looked into the usage of different CHP technologies here. So you see indicated here some of those cases are using gas turbines, some of these use cases use gas engines, and therefore we have like a broad variety of different applications in different framework conditions of CHP. There's maybe one thing important to mention. We've spoken about, all speakers before me and also myself, about hybrids and hybridification of CHP, and that's something that's being done by complementing CHPs with electrified technologies. And in all the cases, we do have very significant electrified generation technologies in these portfolios. And in most of the cases, not in all of the cases, these electrified technologies are capable of meeting the full heat demand. So that means we enable in these setups the generation of most or all the heat that the end user or the district heating system needs to produce also without CHP, and in case of industrials, in Spain and Italy, completely with electrified technologies. Just by hybridizing it, there's not the need to do it all the time, and that like generates the flexibility that allows to actually react dynamically on an evolving market where we see, and that's something we will be seeing. We can react to the changes in the market environment, to the power prices dynamically by either using the CHP or using the electrified technology, or in case of district heating systems, of course, using other components of the district heating generation. We do have evaluated the use cases across those 5 dimensions that I mentioned before. Those are all covered in the full study. We will not, or I will not cover all the dimensions today. So we made a selection that's like amenable to the time frame that's provided, and those are highlighted here, and I will not go through them here on this overview. Just to show you, we have like a sub-selection where we cover like how CHP complements renewable generation. We will look into the energy efficiency. Again, we do not cover all the use cases, but it's a selection. The results of the other use cases are then covered in the full study. We do cover some aspects of decarbonisation, so industrial decarbonisation, impact on the emissions, but also the effect, efficient district heating criteria, looking into the industrial competitiveness industrial competitiveness cost, and we will leave out ancillary services because that's a really big and broad and endless topic to cover. So that's something we're going to spare you for today. So going into case study insights. As mentioned before, we picked some aspects and we also picked some use cases. So top right, you usually see the logo and the flag of the use case that we picked. We tried to select all countries and use cases for illustrating some of the aspects. Here we're looking into Spain, and we look into the ability of CHPs to react on short-term price signals to provide like short-run flexibility. And that's something that's very nicely illustrated here by looking into what's happening in the Spanish market, where we have like in this case 2035, so already looking quite some time in the future. We have like quite a volatile power market. This is like the red line that's basically jumping around, that has like some peaks, but that also still has some zero hours where like electricity is like either wholesale electricity either for free or might even turn negative. And then we see how the portfolio of technologies that we have set up here can react to those price signals. And what we see here is like a relatively easy to understand fact. Whenever the power price is high, it makes sense to use the CHP to produce large parts of the steam and heat demand. That's like the bottom graph where this purple CHP throughout the stack is always purple. So the purple generation block is relatively high when the price is relatively high, and whenever there's like cheap electricity available during noon, when there's like a lot of solar generation in the Spanish system, then the electric boiler jumps in, and we have also included in the setup heat storage, and the heat storage can also store some of the excess generation during cheap hours and put it like in the future. And that's like something illustrating the ability of such hybrids to react to power prices, and that's something that will stay important also going forward in time. Oops, wrong direction. So then we look a bit into the long-run dynamics of CHP usage. And what we've done here, we've contrasted 2 points in time. So basically, first thing is we look into 2025, like 1 year past. Like when we did the modeling, it was still a bit prospective. Where we basically have the current price duration curve, where we have a few hours that are low price, zero price. That's where the one is. We have a few zero negative priced hours, then a plateau of electricity prices and peak prices, and accordingly we have like the generation of the portfolio of technologies, where we again have like when electricity prices are high, CHP produces; when electricity is cheap, electric boiler jump in and produce the heat. When we move down the line into 2040, we see quite a significant shift in the structure of the electricity prices. So the increased deployment of renewables actually leads to a shift in the price duration curve. Like the curve shifts to the right. We have much more hours of zero negative prices. We have the plateau that's basically significantly reduced, but there's still quite a lot of like actually quite high priced hours when there's no renewable generation and when some other generation needs to kick in. And accordingly, also the generation portfolio shifts its usage, and we have like much more production of heat by the e-boiler, by the electrified technology. We have like much more usage of the storage that can actually take up much of the excess generation. And then still, when prices are high, there's the flexibility of CHP to actually generate the heat and profit from the high electricity prices, and avoiding and shielding basically the end users from these high prices. We've then looked also into like long-run dynamics for district heating systems, and there one of the interesting facts, and that's something that we're going to illustrate here on the Romanian use case, where we've modeled the CHP use by a gas engine in Romania. And what we see here is that there's a pretty nice alignment between the seasonal demand for heat and the seasonal demand for electricity that is expressed here by the Romanian power price. So what we see here is The Romanian power price is particularly high in winter times. In 2035 again, where we have less renewable generation here and or more demand. And exactly in those times, there's also more demand for heat, and there's also more runtime of the CHP. So we have again this purple block of CHP generation that matches quite nicely the structure of the electricity price that see in the top graph in the red line. So high prices of electricity, high heat demand, high CHP generation, and this like electricity generation where there's no immediate use in the district heating system can contribute to meeting electricity demand in winter. Next up, we look into again one of the aspects that we already covered before, the question of how does CHP interact with high electricity prices. And what we've done here is we basically take 2030 as a year. We this time look into the Italian use case. The Italian use case is an industrial end user that uses CHP to produce heat and cold for pharmaceutical industrial player. And we again have a hybridized setup. So we have like the gas engines as the CHPs. We have like electric boilers and electric chillers here. And we look into 2030 this time, of course, having the same price structure time series. The price is the same in both graphs. However, on the left-hand side, we have the CHP included in our hybrid setup. On the right-hand side, we have no CHP and actually do have a gas boiler that would react to high prices. So we are not forcing the system to actually use electrified heat all the time, but we basically do a least cost dispatch, and the electric boiler is always used when it's like more economically to use it, and if gas is cheaper than gas is used. And what we see here is on the left hand side we have like a lot of like CHP generation where CHP can produce the heat and also produce the electricity, and on the right hand side we see the e-boiler does more or less the same generation as in the left-hand side, but it's in many hours of the year cheaper to produce the heat with the e-boiler, with the gas boiler than with the e-boiler. So bottom line here is when you have like the option to run your CHP or your e-boiler, and you have the option to run your e-boiler and a gas boiler, then the CHP does not really reduce the runtime of electrified heat, but it actually reduces the need to use a gas boiler. Of course, you could do a more cost-intensive dispatch. You can force the e-boiler to produce more heat, but this will only get more expensive. So it's like basically taking into account also the dimension of like affordability and industrial competitiveness. Yes, you can of course force them to produce more heat in an electrified way, but it will not get cheaper. Next up, an issue that we come across in some of the jurisdictions that we looked into. This is the question of grid connection, and we specifically looked into this topic here in Spain, where this is, as just discussed before the presentation here, is a very imminent issue, that getting grid connection capacity is an expensive process and is also a lengthy process. And what we can showcase here is that basically the electrified, the electrification of heat, the electrified hybridization needs like an increase of the grid connection capacity, and that might be something that's very difficult to achieve. It's costly, but it's also like difficult and lengthy to get this grid connection capacity even. And what we can show in the hybridized CHP setup is that basically you can delay this grid connection capacity for some time. You can use the CHP immediately to meet your heat demand. You can put in an electric, a direct electric boiler or electric boiler of any sorts to basically produce heat within the existing grid connection capacity. So you have grid connection capacity, you also have like on-site generation of electricity. You can use those two to produce some heat, and only over time increase the grid connection capacity to achieve what we have called like the full capacity electrification. So basically the ability of the setup to also meet the complete heat demand in an electrified way, just not already in 2025, because this grid connection capacity is hard to get and hard to increase. And therefore, we can basically bridge the gap in this use case using CHP over the time when there's like no grid connection capacity expansion possible. Next up, we looked into the question of fuel efficiency, and we here look into the district heating use cases. We've done the same exercise, of course, also for the industrial use cases, but here covering the district heating use cases. So we look into Poland and Romania, and the question that we have asked ourselves is, when comparing the hybridized setup with CHP against the hybridized setup without CHP, what is like the overall fuel usage? And the overall fuel usage is a combination of the fuel that's like used on site. So basically, in your CHP on site or in your gas boiler on site if you use it, and also what's like the upstream usage of fuel, because when you don't have a CHP on site, you need to take grid electricity. And in many of those countries, and those two are a particularly pronounced example here, you have like an electricity generation that's still fossil fuel based to a large extent. So when you use more electricity, the marginal electricity that's used by not having the CHP available is in some hours of the year fossil fuel based. And what we look into here is like when you look on the left columns, the non-CHP columns all the time, they basically answer the question, if you don't have the CHP, if you need to source the electricity from the grid, is this marginally produced by fossil fuels, and if so, from which and to what extent? And when you add this upstream fuel consumption to the consumption on site, you basically see that over a long time, like the hybrids, including a CHP, use less fuels overall than the hybrids that do not have a CHP available, simply because you have like more, or one of the key facts is because you have more need for electricity, and this electricity might be produced or might be required in hours when there's no renewable generation available. And to some extent, the mirror image of this fuel consumption exercise is then the question of looking into the emissions, because of course, when you use like fossil fuels on site, you have like on-site fossil fuel emissions. But when you take off electricity off the grid, that's like produced using fossil fuels, then you have also fossil fuel emissions that are upstream. Plus, you have like grid losses that basically are incurred to produce the to ship the electricity or transport the electricity to the site. And what we see is basically when we make the exercise and again look into if we have the CHP available compared to when we do not have the CHP available, and when we need to meet the electricity demand of the user by off-taking electricity, and also do not have the ability to basically re-inject electricity in the grid when it's excess compared to what the end user needs, then we have like more electricity generation for the grid, centralized from the grid. And in the countries analyzed and the use cases analyzed, that's to some extent, to a decreasing extent, that's of course very clear when we look into the involvement to a decreasing extent, but it's still to some extent produced by fossil fuels, and they produce emissions. Just to flag, that's something I forgot to mention. All the modeling is done using the T1DP 2024 assumptions. So we have used like the basically standard assumptions for the evolvement of the power system. So there's like a very dynamic evolvement of the system over time. So up until 2040, there's a very significant deployment of renewable generation, and that's very visible here, where we see the marginal effect is like decreasing over time. So that's very pronounced at the start, and that's tapering off to some extent, but still like over the lifetime of the asset park and over the modeling horizon, that's still a positive effect. One of the more tricky regulatory issues is the issue of high efficient district heating, like high efficient cogeneration, and the use in meeting the criteria for efficient district heating. And what we've looked into here is, again, for all the district heating use cases, being the Polish one and the Romanian one, and we highlight here again the Polish use case, how CHP can contribute to achieving the efficient district heating status using the this technology shares criteria, and how over time this is possible to meet by including a CHP in the mix. And that's something that was also, and that's important, also considered in the non-CHP hybrids. So we have where we have like a portfolio that does not include CHP. So basically, we also have achieved the efficient district heating criteria in this other setup, in this other hybridization setup. But that of course has some operational impact. So in order to achieve this high efficient this efficient district heating criteria, you need to run your assets in a certain way, and that was considered here, and that basically points to the fact that this is like possible to achieve with efficient district heating with a CHP that's included in a district heating system. Sorry. Then we look into the cost competitiveness thing, the dimension of how can CHP contribute to generate heat and energy more broadly in a cost competitive way. And what we've used as a metric here is the levelized cost of energy. So we're basically looking into the question, how much does it cost to supply the energy that's required by the end user or by the district heating system. So we do not, levelized cost is not just electricity, it's like energy here. So that means the electricity that's required by the end user, the heat or steam that's required by the end user, and both put together as the energy delivered, and looking what does it cost to supply this energy over the entire lifetime, over the entire modeling horizon. And basically looking into over the 15 years that we cover in our modeling, how much does it cost to meet all this energy demand, and compare this again in those two hybridized setups, including the CHP and not including the CHP. And what we see that the flexibility that's provided by the CHP to avoid like high electricity prices can help to achieve like cost reductions compared to the electrified setup. And that's like true for all the three industrial setups, and we've seen have similar results also for the district heating case studies that we do not cover here. So, and that's basically the summary of the analysis. So we looked into 5 use cases in 5 different countries using different technologies in different industrial or district heating applications. And what we see is that in these 5 case studies that we analyzed, there's basically a contribution of the CHP usage across all the dimensions that we looked into. So we have like the ability to use like electricity when it's like very expensive. We can avoid the electricity connection queues to get like electrified heat already quite early on the system. We have like the more efficient use of fuels in the fuels, and this can be increasingly also, of course, decarbonized gases by using CHP. We have like the decarbonisation benefit that when we include like in a full picture also upstream emissions from electricity generation, then we have like a positive impact on the emissions. We can achieve using CHP the efficient district heating criteria. The levelized cost of energy can be lower than in the electrified hybrids, and the wider system impact, that's something we have not covered in this slide deck, but it's again in the study. What we can show is that what's like factual is that all these CHPs, of course, can produce ancillary services, and those ancillary services can add a revenue stream to those use cases. So these use cases might be even better from selling ancillary services to the system operators. However, an important thing, and that's also highlighted in the study, not all the ancillary services that CHPs and the technologies can provide are actually remunerated at the moment. So there are some services that can be provided that are also required, but that are not leading to a revenue stream, but some do, and those revenue streams would actually improve the use cases in a commercial from a commercial point of view compared to what we see here. I think that's it. Thank you very much.
So thank you again. And we're running a little bit late. And maybe first of all, to everyone online, we did see that there was a technical issue and we have resolved it. We apologize. Not to worry, we will share the slides with all the registered participants on site and online. So we apologize for that slight glitch, but everything is running again and we're following everything very closely. Are there any burning questions right now? Just looking in the room. Not really. There are obviously ample time in the coffee break. Gerald will be with us, I guess, until the evening. So if you have any questions, you can obviously track him down, and his colleague is here as well, David. So.
Most part of the modeling.
Okay, so I suggest we thank you again, and thank you to Compass, and thank you for all your hard work and your patience with us, and we're very pleased to have this final output, and we're looking forward to sharing more of the results as they become available in the coming days and weeks. So I suggest we move on to the first panel discussion, which will be looking at national perspectives from across the EU. As you've noticed, we have 5 use cases, 5 different countries, so we'll have an opportunity to hear from the experts themselves, from our national associations, as well as I think from the European Commission as well. So not a national perspective, but I say pan-European perspective, let's say. So I'm going to leave you in the capable hands of my colleague Alexandra, who's our head of policy, and she will be running this discussion. So thank you.
Thank you, Hans. Good afternoon, everyone. I am here to moderate a very exciting panel discussion on national perspectives. As you've seen just presented now, we chose 5 archetypal countries that reflect the diversity of EU's energy system, different energy markets, quite different policy frameworks that actually impact the energy mix and impact the decarbonization pathways and the competitiveness of EU's industries, as well as the affordability of energy when it comes to district heating. This panel discussion will actually feature some of the members who are involved, some of the national associations and their experts who are involved in framing the different use cases, as well as different perspectives as well. I think we can kick it off. I will ask each of the panelists to join me here on stage, on this improvised stage. I will start with Ricard Vila, representing COGEN and COGEN Spain. Next is Marco Pezzaglia, President of Italcogen and Chair of COGEN Europe. Hans van der Siepe, energy expert for COGEN Flanders, but I think you can also speak on behalf of Belgium as a whole. Mr. Mihai David, President of COGEN Romania. And representing the European Commission, Heidelinde Andesam, Policy Officer in DG Energy. Okay, so I think the panel is ready. While we have introductory statements, which should reflect your thoughts and reflections on the study results. So you've already seen the study. Is it any good? How does it represent your how does it represent your country's situation? So the current context in your country, but also the future of cogeneration and the future as part of the energy system as it evolves. So I think we can start with intro statements. Meanwhile, we also have a Slido that is happening, that is available for participants who are here with us in person, but also online. So I think you can scan the code on the slide. and share your views on what will be the key driver for scaling up hybrid and flexible cogeneration systems across Europe. So that is the ongoing Slido. While we see answers coming in, I will start with Ricard. What are your conclusions, having seen the study, having also the experience from Spain?
Well, thank you for inviting us to be part of the presentation of the study, and to the hard work that Compass has done in the works and the modelings and the results. How it represents the use case, the Spanish situation of CHP. I believe that the case that we choose and the results that we are seeing are the ones that the CHP can provide with the hardest penetration of electrification in Spain. That is not the case that what we are seeing that is happening. But if in that case CHP can provide reduction of cost, reduction of CO2, grid hardness, I believe, or my thought about this technology is that is one of the best tools that we have in the transition that we want to do.
Okay. I know you have a slide. Would you like to, maybe we go into it next?
Maybe we can go it, because I think it's more about another topic.
Okay. Then next, reflecting on the study, is Marco Pezzaglia from an Italian perspective.
Yes, thank you. We found this study very valuable for our system. It is a system in Italy where prices are high, electricity prices are high, and at the same time there is a very huge potential of increasing of renewables in terms of solar and wind. And so what could be the role of cogeneration for especially industrial customers, because in Italy cogeneration is used mainly for industrial purposes. It's a very important role. I think the most valuable conclusion of this study is that there is not just one single technology that can bring the solution for the final users, but it would be a mix of solutions, because there are not, at the moment there is not, especially for some part of industry, an available solution for decarbonizing heat. And so that they can stop operating, and they need to decarbonize. So in absence, or in a partial fuel switching option, that is using of biomethane or hydrogen, of course we have to find the optimal solution, and we demonstrated as how the real point is integration and not competition amongst technologies.
Thank you. And Hans, how did you perceive the study coming from Belgium, a country that was not covered directly in the study?
Well, the case presented like in Spain is similar. We have the similar elements also in Belgium with gas turbine cogenerations, basically then in the chemical industry. Currently, they still run more or less flat out during the whole year with the additional capacity then or demand of heat covered by boilers, gas boilers. And they are looking into arc furnace boilers and other elements, but this is still starting. In residential and in agriculture, greenhouse, the vegetable growing, there we see actually the e-boilers popping up. We don't see so many of heat pumps because they're more capital intensive. And in the same time, we see also that the cogenerations were perhaps 5 to 6 years ago, were focusing on running regular schedules, start to be operated more dynamically based on the electricity price, and the e-boilers coming up as a contribution like for supplying low temperature heat and hot water. And this is developing, and then you see Also, like the study says on the Spanish case, where we see that the number of running hours of the e-boilers is actually still limited. But the cogeneration, which was first focusing on primary energy savings and was supported through a scheme based on primary energy savings, has to find other revenues because that support is stopped. But they found actually a role in grid services and in security of supply.
Okay, very, very interesting and encouraging. I will move on to the Romanian perspective. No. Okay. Thank you. We will move on to Heidelinde, who will reflect on the study from policymakers' perspective. Yeah, you're preparing the heating and cooling strategy, the electrification action plan, and I think part of the purpose of the study is to inform policymakers, both at national level but also at European level. So do the results of the study help you in seeing a future for cogeneration in collaboration or in cooperation with other technologies?
Yeah, good afternoon. And first of all, let me thank you for the event and also for the study. As you said, we are working on a heating and cooling strategy, electrification action plan, and as always for those initiatives, there is a call for evidence, open public consultation, and I have to say that many of the issues that were covered in the presentation were already brought up in the statements, in the very valuable and high quality statements that we received in this open public consultation. However, what I think that is the benefit of the study is that it gives evidence now to this. It's not only on a qualitative basis where stakeholders tell us what would be important, what are the developments that might be expected. It really gives evidence, it gives figures, and you know we all love to have some figures in the back for our strategies. So this is, in my view, the benefit of this study.
Thank you, great. And Mihai, Mr. David, as we would say in Romanian. Yes, so you represent Romania, but you also represent the district heating sector. So how do you read the study from a district heating perspective and coming from Romania?
Thank you very much, Alexandra. First of all, I would like to give my deeply thanks to Compass Lexecon, to Gerald and to David for the study they made. It's for us, it's very important to show our case into Europe. I mean, we are a bit envying the Western European states for the problems that they have. We have not arrived to the level to have that type of problems in Eastern Europe. We managed to close most of the industry after 2007, so we are not addressing this type of problems of the industry. What we can address is the subjects regarding the district heating. We are looking to the models from Spain, Germany, and Italy because this will happen in the next maybe 5 to 10 years. But today it's out of any question. Our biggest problem is that everybody here in Brussels, in Western Europe, is talking about electrifying. So we agree in principle, but we have some problems. I mean, out of the last report about the Romanian National Energy Investment for Climate Changes Plan, I give you two figures to understand why I'm saying this. Then up to 2030, Romania have to invest close to 7 billion euros in transport for electricity and between 9.2 and 11.5 in distribution. That means we owe to the national grid around 7.5 billion within the next 3.5 years. I mean, this money, we don't have any chance to get it. So, what we have to do, clearly, we have to go for a solution to help us implement the policies, but in a different way. That this solution is district heating. And the study represents exactly which is the solution for us, and I think also for the Polish case, is the same thing. Poland stays better than us, and I'm happy that you are here, because the message from the board, from the eastern board of the empire, is that when you look to policies, put in small parentheses, a solution, awful for the poor guys trying to recover 50 years of delay. Thank you very much.
Okay, thank you. We can now look at the Slido responses. So this is the word cloud for the role of cogeneration in the future energy system. So we see balancing, so a more flexible cogeneration fleet, efficient use of valuable resources. I guess that's also clear from the study. With CHP, we managed to reduce fuel consumption. So that's primary energy efficiency, or efficiency at system level as well. Energy security, that's also a very important aspect. Targeted but important. So indeed, even as COGEN Europe, we don't say that cogeneration should be installed everywhere, but we think that there are many applications where cogeneration can complement other solutions, and we are always advocating for an integrated energy system that makes use of the advantages of all technologies available. Funding the backbone of the energy system, that's nice and very poetic. An energy efficient supplier. So supply side efficiency, we see at European level quite a lot that there's quite a strong focus on demand side efficiency and final use. But then we also have to look at how energy is produced, transported, transmitted, and consumed. So I think in the future we will be looking at, or we should strive for more efficient and smarter ways of both consuming and producing energy, as well as transporting that energy, hopefully on not so long distances, so locally among producers, prosumers, and consumers. Then I think we can do a follow-up round. Maybe I can start with you, Marco, on the situation. I'm putting you on the spot, but I know you have some slides presented with a study that was carried out in Italy, which actually echoes some of the results of the COGEN study. So maybe you can reflect a bit on how Italy sees the future of cogeneration under different scenarios.
And indeed we try to complement this European study with the national one, let's say a twin study. Of course, we made it more trivial than the complete European study, but we also have the need to make it simple for our policymaker. And I want to take very few minutes, because I will try to be as much as efficient as I can, but probably, yes, I start, okay? So we try to reasoning from a user perspective. So we have a traditional use mode of cogeneration that is heat-driven. So it's a flat, behavior, but we have invited by our TSO to think about what's happening during the hours of the day, because it says we want cogeneration, we want to lose cogeneration, we do not want to lose cogeneration, but there are some points in the days that are not necessary for the system. But what we say, we are necessary for the user. So what to do? And at the time, during the day, where the market price is lower than the production cost of the local production cost of cogeneration, what to do? We have two alternatives. So if we would like to make it simple, to run off cogeneration, and in this case, you have to produce heat by another way, for example, by boilers, fire integration boilers, or maybe you can continue to run cogeneration and to manage this need of the system by flexibility solutions, that is using storages, for example. What we did is to study these conditions for an hypothetical user, industrial users that doesn't have any other alternatives to electrify the heat production in different scenarios of penetration of renewables in Italy. These are real scenarios for Italy, starting from now to 2040. And of course, you see how the market price modifies its behavior at the increasing of renewables into the system. These are real data. This is the real market of Italy. And this is an example of the various studies. In the four scenarios, we try to measure the avoided emissions, for example, in the case of heat-driven, CHP on-off with integration boilers, steam boiler, of course, and the alternatives of continuing to run cogeneration in an efficient way for the user, and managing electricity in order to make it flexible for the system. And these are the results. The main results is this. Cutting off cogeneration is never a good solution, both for user and for the system. It is the condition where the avoided emissions is lower, and when the efficiency lost, the loss of efficiency for the system is the maximum condition. So it is not a real condition. The best condition is continue to run cogeneration to produce heat for the user, while managing electricity in a flexible way. And so this is the conclusion that we found. The switch off the cogeneration always is economical for the consumer, and reduces the efficiency and the emissions avoided. So this brings us that flexibility is the key for this, and for having flexibility, integration with other technologies for flexible managing of the energy are the keys. Of course, we could also reason about to see heat pumps combined with CHP and so for increasing efficiency and so on. But this could be seemed trivial, but we have also to think that final users cannot install on site all technologies for integrated every condition. It must do some choices. So we want to present a simple alternative, and then, of course, the users will do their choices.
Yes, thank you. Thank you, Marco. And indeed, this reflects very much on the conclusions of the Compass Lexecon study that in the future, CHP will remain important, but then its operation will have to adapt to the changing energy system. Then maybe turning back to Spain, we are today hearing a lot about Spain because of the current context. We have the energy crisis, we have potential disruptions of supply, and quite high price volatility. And Spain is being showcased as a champion of the integration of renewable energy production, which has an impact. So we hear that PV and wind are of course, the cheapest sources of electricity today, and Spain is one of the champions in renewable power integration. So how does that play from a cogeneration perspective, given that there's a lot of industrial users that have cogeneration? Is CHP still relevant? And yeah, how do you see it from a Spanish perspective?
Yes, I am going to do it with only one slide. There's a lot of information in this slide, but the main issue is that I want to try to follow your question with the study that we did. The study that we did has a 2025 number that it's, let's say, pretty accurate, that what can be done in Spain in one use case with CHP and with electrification systems. But because Spain has a lot of renewables, and you are seeing from here that we have a very low electrical price in the market. But that's not true. It's true, but not at all. We have a day-ahead price market very low. But we have a restriction market that has increased 500% in the last 5 years. So as much renewable we have, the primary market goes down and the restriction market goes up, higher than the day-ahead market goes down. So the final price that the end user is seeing is not going down very high. For a generator point of view, for the excess energy that the CHP could have, you are seeing the day-ahead market. So you are seeing zero for your electricity. With a renewable new installation, you are seeing zero. But as an end user, you are paying all the restrictions that the massive renewable sources needed for the regulation of the system, because they are not as much as distributed as a CHP could be. So for a self-consumption point of view, something that I said that is the best case scenario against the results of the actual CHP is that the path that we are seeing are not following what we are seeing in Spain. We are looking for a decrease in electrical price that is not considering the regulation cost, the distribution cost, all the grid infrastructure that we request for this massive increased consumption. In Spain, we are not developing. I'm here representing COGEN and COGEN from Spain, but I'm not working there. We are helping them as AESA, that we are an engineering company, and we develop solutions. We go to the industry and we try to help them to reduce their energy costs with whatever we could. We sell ideas, we sell projects, we do projects, and we are not doing anything in electrification. Yes, in some cases with several heat pumps, when we have low temperature, but we are not doing that in industry in Spain in massive, for two things. The first one was the total energy cost that the users are seeing, because they are seeing not the primary energy market, they are seeing the overall cost. And from that cost, we can have 2.5 to 3 times higher in the electrical bill. And we are going to use that cost for electrify our thermal demand. And the second one is that 80% of the grid, and this 80% is in the industry areas and in the big cities, is in a high tension and is fully congested. So you cannot request 1 extra kilowatt. So the fact is that requesting interconnection in Spain nowadays, in terms of demand, is asking 5 to 8 years to get an answer of which type of infrastructure the end user has to pay. So cutting other tools that could help in terms of transition, helping in reduction of cost, and helping in terms of infrastructure, because more distributed generation would help the actual only user that can afford a minimum electrification is the one that has CHP, because it's the one that has more interconnection capacity than the actual request of electricity that the factory has. So cutting this or letting not all the technologies help them in this path that we have to follow to achieve a goal that all of us believe in 2050, I believe it's not true, because it's not fair, because there are plenty of things that could be not good for all of us in Europe in terms of cost effectiveness.
Okay, thank you. So what I gather from your explanation here is that CHP is one of the solutions that can actually help speed up the uptake of renewables and the uptake of electrification. And that relates more to infrastructure constraints than the potential of renewables by themselves and heat pumps of delivering efficiency and decarbonized electricity on their own. So in a way, in a vacuum, a heat pump is very efficient. Also, by themselves, PV and wind are needed for the energy transition. But then when deployed, we need other technologies to facilitate their uptake. And yeah, this makes a good transition to the topic of infrastructure and grids. And maybe from a Belgian perspective, how do you see that evolving? Because electrification will deliver additional electricity consumption. For that, we need additional generation and additional grids. How does that? What's the evidence from Belgium?
Well, the TSO currently is, you have a capacity remuneration system in which the CHPs are allowed to participate, which is a good thing. And what we see is that when they look after the needs they might have in the future on additional generation, they actually count that the existing cogenerations will remain in the market, because they know that if a cogeneration stops and would be replaced by an electric boiler, you reverse the logic of, instead of having an injection of electricity, you start to have a consumption of electricity, so you're penalized twice. This is a point where they hope, and the capacity remuneration system allows cogenerations to participate, so it should work that existing cogenerations stay. If you look at the distribution grid operator, he is pretty much in this situation where somebody who is a low consumer of electricity starts to look at electrification of his heat, because he's also a gas consumer, probably a bigger, larger gas consumer than electricity consumer, and he's asking for an additional connection. And then you come to the point where Compass Lexecon has also pointed out that the fact that, look, you can go on electrification, but there is no room in the distribution grid to welcome you without strong fortifications. So we are now running into the thing of flexible connection agreements, where the logic is that the grid will, in this development, catch up with the increasing demand on the grid. But at the same time, we see that the companies wanting to electrify also perceive electricity as a more volatile product than the gas product. So the electricity prices can go times 10 in 2 days' time, depending on the weather. There's a lot of solar in Belgium, and this means that if he can switch that risk to, instead of volatility of electricity prices, to a volatility of a fuel price, which can be a renewable fuel, it allows them to have a more predictable business plan of what he's trying to do in his decarbonization effort. The distribution grid operators are pretty much afraid that too much of the capacity available will go to electrification of existing companies instead of new developments or new companies arriving in the scene, new business plans, new opportunities which cannot be fulfilled or which cannot be served. And this is a point where, as Cogen Flanders, we believe that more and more we will have to look at local systems, where probably we'll have the compact Lexecon hybrid mode, where you have an on-site generation, but also an on-site production of heat using electricity. So electrification together with the production of electricity. In Belgium currently we have the issue that the CRM has rewarded 15 years contracts for large CCGTs of 800 megawatts. But then you transfer the problem from the production side to the transmission side and the infrastructure of the grid operators, which is currently an issue, or becomes an issue that, okay, when the grid is full, also the transmission grid starts to be full if you have centralized electricity production instead of decentralized.
Okay. And then also touching a bit upon the district heating aspect and infrastructure. Of course, for an industrial user, the ability to get a grid connection or expand their grid connection, that is critical and it's costly. But then also for district heating, we see that district heating is one of the solutions that can relieve pressure on electricity grids. We also see that at least the narrative for district heating decarbonization does go more and more in the direction of electrification because it's low temperature heat. So then it should be easy to decarbonize via electrification. So how do you see the combination of the two, so cogeneration and electrification, in the context of district heating and in the wider context of energy infrastructure?
So, Romanian case is a very particular one. We have to keep in mind that we have the biggest natural gas reserve in European Community and the second one in Europe after Norway. Then we have the problem of the investment in the grid to be able to cover all of these transmission needs for the national grid that I've told you before, which will be 7.10 billion in the next 3.5 years. Now, the logic is simple. You don't need to be an academician to understand that the solution is to expand the district heating using for a smaller period of time the possibility of having this reserve of natural gas just to stabilize the grid and to give the opportunity for the renewable energy to increase the production levels. Here is also a problem because we received the roadmap from Brussels that we have to increase the renewables, but we didn't know how to read it very carefully, so we invest a lot in solar panel and in batteries, for which the Chinese people will be thankful to us forever. But we have not invested a lot in the wind. Yeah, we do have the chance of the Black Sea. You see what's happening on the coast, western coast of the Atlantic Ocean. You have a lot of investment from the western states. In the eastern states, nothing. I mean, our problem is that I think we need more time than we originally thought to understand exactly which is our way, yeah? And I do not think that we still have this time because you know, our district heatings, they are high temperature district heatings. It's the way we have inherited them. And we kept investing in them to modernize, to do all of these things, but we still have the high temperatures. So when we hear about district heatings and the question of how you heat the big urban developments at low-grade heat, yeah, for us will mean that we have to take it from zero. So the investment needed is big. So where to spend the money that we have, first of all? In decreasing the temperature of the heat, in supporting the grid in order to have a lot, I mean, the capacity to increase the capacity of the distribution and transport lines, or to start to give life to former CHPs that we have in the country and we close them, part of them still unmodernized. Yeah, the simple solution is that we have to go for this, because district heating is a sort of avoided consumer, bypassed consumer. Once you have a district heating in an urban development, you have the chance locally that you can produce the heat and you also can produce the electricity is needed for that urban environment. So as many as you have a distributed power and you have a distributed heating, which makes sense for us and will give us the chance to get at the horizon of 2040 in a position that we could have come up in a short period with all the differences between West and East, and we'll be able to be at the level of Western European countries by 2040 and looking to a 2050 without emissions. Hoping to do this, What I can tell you is that we are still looking through fog at these subjects, and unfortunately, between the executives and the policy side, there is still a huge gap, and we try to do all our efforts to close this, to narrow down this gap, so we have a clear plan how to do it. Thank you very much.
Okay, so it's, I guess, all about making choices, and maybe the message is that all relevant choices should be kept open. So rather than narrowing the array of options to the industry, to policymakers at national level, we should try to allow for different options and also their hybridization. And yeah, Heidelinde, we see now we are in quite a particular context with a competitiveness crisis, an energy crisis. How does DG Energy think about energy efficiency, energy hybrids, and the future of decarbonization? And I mean, we saw that Accelerate EU came out yesterday. There is a strong focus put on energy efficiency, electrification, renewables. So yeah, how do you see cogeneration fitting in that context? And yeah, how would you reflect on the current context and how Europe's decarbonization pathway is coming together?
Yeah. I mean, in my view, the benefits of CHP are, first of all, the system efficiency. So meaning that instead of producing only electricity, you make use of heat. This is definitely a huge advantage that this technology brings with. The other point is also the flexibility, and it's a pity that in the study it was not the main focus, or it was at least I think you said it's the system benefits that the cogeneration brings with is not really fully measured in your study, because I think that this is the second most important benefit that cogeneration brings in a new framework, in a new heating, cooling, electricity framework. Within this new framework, we will have, as you said, a lot of electricity. Yes, electrification is a backbone of the transformation, of the energy transformation, the energy transition. However, to transform a system as we have it now into a decarbonized, highly electrified system, we need technologies that bridge between what we have for the moment and what we will have, what we want to have in future. And in my view, CHP is such a highly valuable bridging technology that helps for the moment, as the system is designed now, to deliver a pathway with less cost than other technologies to transform what we have now to a decarbonized electricity and also heating and cooling system. So system efficiency, the flexibility, the services that heating and cooling with CHP can provide for the electricity grid. And also it's a local technology. It's on a local level. And this is what we also think is very important for a new system, that we have localized supply and demand finding together. And so these are the benefits that I see with CHP in a new system. And what we think what will help to keep the important role that CHP has is we need, and I heard it today many times, we need to integrate. We need to think integrated. And in our view, this can best be done in planning. So we think that we need to integrate, that we need to make use of integrated planning on the local level with our local heating and cooling plants that we already established in the Energy Efficiency Directive, linking this with other planning levels on the horizontal level, meaning with electricity, gas grid plannings, but also with spatial planning to have also the demand for heat in the integrated planning, and also to integrate it vertically. So, meaning different authorities, different stakeholders, TSOs, DSOs, the municipalities need to be integrated in these plannings. So this is one of the aspects that we think is very important, and I fully agree with the hybrid approach. We think that the future heating, cooling systems will not only focus on one technology, there will be a variety of different sources that in an optimal way act together to produce the required heat. And we don't want to push for 1, 2, 3 technologies. Yes, of course, electrification is quite cheap with the heat pumps that we have on the market now. It's a quite cheap solution. However, with an overall system approach, it is needed to compensate the volatility that we have in the electricity grid by the renewables, but also the volatility that waste heat use, that we want to push for waste heat usage recovery, that also there is an aspect of volatility, and these volatilities need to be backed up by a stable backbone. And CHP is, in our view, such a stabilizer of the system, because it can be used whenever needed in an optimal way. And so, therefore, having in mind that a new system requires a variety of technologies, not only one single technology, CHP will play also, in our view, a role here. However, not in the common sense as we had it in the past, not as a single player, but in combination with other technologies and on a decarbonized level, of course. So, not based on fossil fuels, based on, for example, biomass. And also here we see benefits that CHP bring, because we see biomass as a resource. It's for us not only an energy carrier to burn, it's a resource, and we want to use biomass in a way, in a circular economy way. So needed to be in a cascadic way to be used. And CHP gives the possibility also to use a lower energetic levelized biomass than other technologies. And therefore we see also there improvement in the efficiency of biomass use in combination with CHP. This is also one of the aspects that we touch.
Yeah. Okay, the added benefits. Okay, thank you for that comprehensive response. Indeed, with CHP, we see it as a stabilizer and integrator of energy vectors. And what is more is that cogeneration indeed mostly relies today on natural gas, but we see a clear move towards renewables. Biomass is one of those, but also biomethane, biogases. There's a lot of use cases in Italy where CHPs are already running on biogas. Hydrogen, nuclear is another option for CHP applications. Maybe I see Hans wants to react.
One of the advantages, I think, working decentralized and localized, is the fact that if you switch from a natural gas as the primary energy and you switch to a renewable source, fuel, you can do this gradually. You can work installation by installation, and so you don't create a hiccup in the offering of suddenly you need large volumes of renewable fuels, which is not there. It's expensive. It's still expensive. It's developing gradually. And if you want to have a 800 megawatt power plant transferred to a renewable fuel, suddenly you need a lot of additional renewable fuels to be developed in one go. And with cogenerations and working localized, like you said, decentralized, that model allows to have gradually and economically pick up this transition. And I think it's going to work then, because otherwise people will not take the risk or do the investments to have huge volumes in one go.
Yeah, and I think you could compare, for instance, CHP and heat pumps. Heat pumps are the most efficient solution to utilize electricity. And we know that not all electricity, our electricity mix is not renewable, fully renewable. So as the electricity system becomes more renewable, then heat pumps are also decarbonizing while providing efficiency. And then for CHP as well, CHP is the most efficient way to use a fuel, a thermal energy source. And with gas grids, we see that gas grids are integrating more and more biomethane. The study actually reflects that, taking TYNDP projections of biomethane in the gas grid. So that's one way that CHP can further decarbonize the energy system. And indeed, we've also seen some studies where if you use biomass or biomethane in CHP compared to a power-only plant, then the emission reductions are doubled with CHP. So the contribution of decarbonization of biomass or biomethane or biogas is much higher when used efficiently in CHP versus less efficient alternatives. So that goes into the direction of, okay, we should prioritize those valuable renewables for CHP. Maybe I can ask a question related to this to Marco, because we see that Italy is quite advanced on biogas, biomethane. How is that transition going? And what are the links to the cogeneration fleet?
Well, biogas at the moment is used in cogeneration, but these plants really don't use the heat. And so the solution is to convert biogas to biomethane, inject it into the grid, and to use it for decarbonizing gas consumptions. But just if I can say a point from, if I can go to this, there is, I think that in this room nobody is against electrification, and of course nobody is against decarbonization. But there is a line that I neglected to show before, that is the green one, that is on the right side of the right figure, the right picture. That's the cost of heat produced by electricity, steam producer. And it is ever higher than producing heat by cogeneration. And to be in favor of electrification, we didn't change why first of all is not zero in a scenario where, in a scenario 4 where the price is very low, electricity price is very low. It is not zero because anyway the customer, the final user for having electricity must be grid and a balancing cost and a dispatching cost. So, and to be in favor of electrification, we didn't change the cost of grid and the cost of redispatching for the final customers among 1 and 4. We kept it constant, as a constant. So I think that electrification could be good, but the story must be completed, must be completed. So, of course, no one of us has the numbers for demonstrating what will be the future, okay, of course. But the models must consider all the variables. And electricity, in the case of a very big expansion of electricity, of electrification, will be probably more costly from the point of view of grids and balancing costs. This must be taken into consideration. This is my point.
Okay, I think we have a few more minutes for one or two questions. If there's any question in the room or online. Hans, you want to co-moderate with me then?
Tag team. Let's see. Can the benefit of combining thermal energy storage, including seasonal storage, with CHP be quantified? And what is the role of thermal storage in the future when it comes to CHP? I don't know.
Is the question, have we quantified it?
Have we quantified it? Can
yeah.
we quantify it? Are there examples of using thermal storage for high temperature?
If you want, I can catch the question and try to answer it. I believe that in the study it was well implemented, so but in the way that we are looking the heat storage from the power to heat systems. But for example, now in Spain we are looking the storage systems for the CHP, based on that we are looking for flexibility. As I showed you, we have a primary market that is what the excess energy of the CHPs are seeing as another generator, and the cost of the users. So CHP is seeing as for his excess of electricity that he has to downgrade or stop his production in some hours. And in that case, what is happening nowadays in Spain is that the cost of this gap of thermal heat that is not provided efficiency by the CHP has to be provided by another thing. And nowadays, this is not provided by an electrification solution. It's provided by natural gas. Because for the full cost that the user has to pay, the electrification system is not competitive against gas. So what we are seeing is that in the meanwhile that these restriction costs are not getting down and helping the electrification solutions to be competitive against natural gas and CO2, we are seeing that CHP that is adapting his way of work to what the system needs from his excess of production can store heat to cover this amount that would be covered with the lowest efficient system in terms of emission. So now we are going to have an action in Spain for extra CHP, 1,200 megawatts. And one of the things that is implemented in the new CHP, or the new scheme of CHP that Spain is seeing, is that we can integrate or we can consider the storage as part of CHP. Because the role is integration of things, as it was said. And as working in the Spanish sectors, what we saw is that what can be done has been done. If you have low temperature thermal request, you have a heat pump. But actually, you cannot go more than that. If you request steam, you cannot go with this system. So you are looking, as a producer, the less cost in your energy as you could, because your product lives for that.
Okay, I see that Mihai and Hans.
Yeah, well, to answer the cases I know in Belgium where they have both the electrified heat and cogeneration, they all use storage. They so water storage, big tank. It comes from the greenhousing, the agriculture thing, where they want to actually stop the cogeneration on a Friday evening and go through the weekend, and then on the Monday start the cogeneration again. That's what's the objective. Now these days, like Alpro, they have included storage in order to be able to flexible and to be able to actually to have different levels of water and even steam. And also, if they want to cover with mechanical vapor recompression and all these things, we see storage coming up. And there are studies about storing heat in rock logic, so that they can provide steam as well. But this is still innovative. But you see, everybody wants to have the peak of the solar injection, wants to use that, and actually use it to consume later heat or produce heat later with as less possible fossil fuels as possible. And this is, I think, storage is going to be a technology which is as important as heat pumps, high temperature heat pumps and e-boilers. It's going to be actually crucial for the energy transition.
Is it mainly low temperature heat, or are we talking high temperature heat?
No,
for the
they go to
industry?
110 degrees.
Okay. And Mihai probably wants to talk about storage in Romania as well.
Yeah, we started to do this because we need flexibility. This gives a lot of flexibility. I mean, I do not imagine the future of e-boilers without the storage. Because, look to Denmark. Look to what, the answer is there. Whoever has this question, they have to look to Denmark, yeah? And to the prices they have for district heating the past year. Close to zero, everything. Because they use the green energy provided by the windmills during the night, where the price of electricity is close to zero, or minus, and they integrate it with e-boilers, with storage, and they realize unbelievable results. Yeah, this is one of the models where we have to use in Europe, where we have the possibility to have wind farms a lot, especially offshore. Also with the inshore you can, but most of it with the offshore. With the solar electricity is difficult because you have the maximum during the midday where you have consumption, you have this, you do not have, starting with the evening, you do not have any electricity renewable. But with the windmills, I mean, speaking about the Eastern Europe, there you have a particularity that wind is blowing mostly, I mean, on average, if you look, half of the time during the night. So this is a lot of energy you can use for district heating. And I really do see it like must-have technology with the CHPs to be integrated into CHP in order to be able to have this. Secondly, when you speak about heating that you can harvest from different industrial use of the CHPs, we are used to this because we are coming from 50 years from communism. Yeah, so it's. If you look to harvest it, the extra heat that you have from the big industrial companies, then you can integrate it only through a storage into the district heating, which is also valid for the cooling systems. Thank you very much.
Additional questions?
There is one that caught my eye, but I think it's a good introduction into the next panel session, which is focusing on, taking into account gas prices that we have today. Is it still efficient to invest in these types of energy capabilities? But it's a good question to put forward to the end users in the next panel. And as you heard, Zoom wants a break. So I think this is a perfect segment to thank the speakers.
I prefer to answer at any case, because cogeneration initially and still is a way to save primary energy. And when you calculate the business plan of a cogeneration, the higher the value of the primary energy you save, the better your business plan is. So is what's happening now, it's not good for our industry. But the picture for using cogeneration is mixed. Your end user is struggling, which is bad. But on the other side, your profitability on selling two types of energies, an electricity and a heat factor, which is probably linked to the value of the fuel, then it's beneficial. So it's. I don't advocate for high electricity, high gas prices, but in any case, I think it's...
Saying in another way, if you have a CHP, when prices go high, you save more. So you are more competitive than the other people that doesn't have this solution.
Okay. I think this is a good moment to stop and to thank the panelists and our moderator for an interesting and lively session. A lot of information, a lot of perspectives. we can continue to do this over coffee. I suggest we come back here at 3:10 to kick off the second and last panel session. So please put your hands together to our panelists and moderator. And for everyone online, we will be back at 3:10. So everyone is coming back. So welcome back to the second part of our study launch. And welcome back to everyone online as well. So the next session, we're going to hear from end users as well as from the European Commission to provide that context, that perspective. So we'll be bringing together representatives from industry, policymakers, the Commission, as well as international organizations to reflect on the study's findings from a sectoral perspective, drawing on sector-specific experience, so coming from the ceramics industry, coming from the paper industry, and also coming from an industrial user as well. We'll examine how hybrid or flexible cogeneration solutions can support decarbonization whilst continuing to safeguard competitiveness and security of supply. So I'm going to invite the panelists to the stage, and I should maybe start with the one panelist that will be joining us online. So I'm very pleased to welcome Dr. Andre Jensch. He's the program manager at the International Energy Agency District Heating and Cooling Initiative. He'll be joining us remotely. And then in person, I'm pleased to invite to the stage Magdalena. She is the Climate and Energy Director at the European Ceramic Industry Association. We're very pleased to have her join us and share her perspectives. And then Eric Lecomte, who is a policy officer at the DG Energy at the European Commission, the unit responsible for digitalization, competitiveness, research, innovation. Next, I'd like to invite Jan Scha. I'm Dutch and I can't pronounce this, I apologize. Managing Director of Energy and Climate Policy at the German Paper Industry Association. So we're very pleased to have him on board as well. And their association has also been involved in terms of providing their perspectives on the study as well. So we're very pleased to have them with us in person with us today. And then finally, last but not least, Laura Blažević, who is the EU Affairs Officer at Metlin Energy and Metals. So we have an industrial perspective as well, an end user, so to speak, to share their perspectives as well. So how things will work is I'm going to invite the panelists to use the first 2-3 minutes each to provide the introduction and their initial perspectives on the study results. Obviously linking that and focusing that on the industries, the sectors that they represent, and maybe identify the parts that you found particularly pertinent to your sector and or supportive, or maybe perhaps what is lacking and still needs further investigation. So maybe starting from the far end, so Magda, you can start. The floor is yours.
Well, thank you very much. First of all, I would like to thank you for the invitation to this panel, of course, on end user perspectives, and also for the study. I think that's really the right moment to ask for such a study, and I'm very pleased to see also the promising results. So thank you for sharing with us. A few words about myself. I represent the European ceramic industry. The cogeneration technology there is broadly applied. In fact, to give you some numbers, it's most popular for our production in Italy and Spain. For products which are very heterogeneous and diverse, it can be ceramic tiles, wall and floor tiles, but also bricks and roof tiles and so on. Also other countries, even here in Belgium, we do use CHP units. In Italy and Spain, it's around 30–40% of electricity that is self-supplied by the cogeneration units, so it's large share. We have roughly around 30 cogeneration installations in each of these countries. So, as I said, I welcome the study, also that you decided to discuss the topic. It's the right moment for discussion on our decarbonization ambitions also and the flexibilities. From the perspective of energy-intensive industries, that's definitely very promising. Currently, our industry is using natural gas and also electricity. But in the roadmap that we have produced already in 2021, we see that there are different decarbonization pathways possible. There is direct electrification. There is also the use of green hydrogen and the use of biofuels that could be applicable for our production. We have to be realistic, however. We see that, in fact, the decarbonization process is not really progressing at the speed that we have foreseen in 2021, in the sense that the conditions that we had when we were implementing the Fit for 55 package since 2022 have altered. And maybe there is less optimism right now, but I will speak about it also a little bit later. What we observe, of course, is the reduction of emissions, but this reduction is not due to the decarbonization investments. Majorly, it's due to the reduction of activity. And since 2022, we have lost in Europe, on average, around 30% of ceramic production. Of course, it's due to the very high energy costs and carbon costs that are also connected. It's not only the question of the alternatives that are not available, but also and majorly these are the consequences of the crisis on the price of natural gas. Since 2022, the war in Ukraine, the price is double, and now we are confronted with another threat of a global energy crisis with the Iranian war and the insecurity, instability in the whole region there. So I think that's the reason why this discussion is timely, because we do need to look at all transitional options as soon as possible. We need to look for flexibilities. And from the study, I read that the cogeneration technologies actually fit for that. So that's good news. I would like to mention 3 benefits, significant benefits that we see for the energy-intensive processes. With regards to energy security, also resilience of the energy systems, then also decarbonization and even the cost competitiveness for the producers. So mainly on the energy security, there are a few elements, of course. There is no doubt that we need to integrate the renewables to much larger extent in the industrial processes. The homegrown clean energy is definitely the right wording. We've seen it yesterday in the Accelerate EU. That is definitely an advantage for cogeneration, that we can achieve the complementarity with other technologies. And here we can combine it with heat pumps, with the solars, with the heat storage, and so on. Also, the benefit is delivered through flexibility. As you know, these processes run 24/7. So this is a very high challenge, especially for the integration of the renewables. And if cogeneration can help us avoid those high price, those peak hours, that is definitely something that is worth investigating. Then, of course, the grid connection capacity that has also been already brought up. It's another element that is very challenging for these processes. For the moment, one of the biggest challenges of electrification is actually the grid connection. So for the long queues on the grid connection, if cogeneration can help, again, that is something that we will look into it. Yes, what I also wanted to mention on decarbonization, another element that is worth to look at into more detail here it is particularly for the systems where the power systems that are not yet fully decarbonized, and we know that in many member states it's the case. In fact, it's not straightforward, it's not a linear process even. So we need to remember that as well. Another element for the decarbonization is the question of the ETS system that our industry is under. And here, what I would like to mention that we believe that it can also be helpful, but the cogeneration need to be better valorized in the ETS. Again, one thing on cost competitiveness, we need to stay cost competitive, that's for sure. From the German case study, I see that there is such consideration, but we need to point in with one element, which is the necessity of the selling back to the grid, which is, of course, the very important element also for us. It's not always a given or a easy case for industrial in all countries. So even though there is no specific case on ceramic plant, I think your presented benefits should be looked into, and this is a very promising option, especially as a transitional solution. And so specifically from the policy point of view, yes, this should be definitely tested.
Thank you, Magda. Yes. Thank you for sharing those perspectives from the ceramic industry as the Pan-European Association. Maybe looking towards the national perspective, I turn to Jan, and we did have a specific paper use case focusing specifically on Germany and representing the German paper industry. We would be very pleased to hear your perspectives on the results of the study and any other further insight you may have in the German case.
Yeah, thank you very much. First of all, thank you very much for the invitation and to contribute to your study. Just a few words to me. I'm representing the German Pulp and Paper Association, and this industry is very energy intensive. We have a high demand in steam, so in electricity. So cogeneration is a very important technology for us, especially since in many cases you don't have the grid capacity for electrifying everything. So you're really depending on some kind of solution where you can produce electricity and steam on site. And so cogeneration makes a very high share out of our steam and electricity production. It's nearly 50%. And I think one very big issue we saw with the study is that our energy system is evolving, and we as an energy-intensive user have to evolve with it. And we see a more flexible system, but we still need to make sure that our baseload production meets its demand. And so cogeneration, especially if you can make it flexible, is a very good solution to fulfill these demands.
Thank you, Jan, for sharing that. And we'll have some follow-up questions specifically to the German use case in Germany. Maybe turning to Laura now. You represent a company that is an industrial company, but also a company that uses CHP for industrial purposes when it comes to alumina and so forth. So we'd be very keen to hear what you have to say about the study. And I think you've had a similar study with Compass. I wouldn't say similar, but you've had your own study with Compass Lexecon, and then maybe you can draw parallels to that as well.
Sure. Very, very happy to be here today, and thank you for the invite. As a bit of background, before I dive into my opinion of the study, at Metlen we are very active in the energy sector, so electricity and gas. But we are also very active in the metal sector when it comes to alumina, as you mentioned, but we also have an integrated approach to that. So we mine bauxite, we produce alumina, and then primary aluminium. And we use high efficiency CHP that's run on gas in the production of alumina and alumina refining. So this is quite an important part of our operations. What I found in the study very interesting is first the complementarity when it comes to CHP and electrification. That one will not replace the other, and I think this is very important. I mean, fully electrifying everything seems good on paper and in theory, But we have seen actually the electricity consumption fall by 7% since 2022. And we've also seen that it doesn't work for all industries at the same time. So the second thing is also the cost competitiveness that was in the study mentioned, especially when it comes to gas-fired CHP, which remains the most cost-efficient and cost-competitive solution we have. And this is very important as well because natural gas seems to be the best solution for now and for the foreseeable future, well into the 2030s. So this was very well reflected. And the last thing I would say is probably flexibility, which was mentioned quite extensively and is still being mentioned quite extensively. CHP can provide flexibility, some flexibility as we've seen in the study. However, primarily for us, it serves for baseload. It's a baseload solution. The process of alumina refining is not designed so much to ramp up and down the production because you have actually a loss of energy efficiency, which is sort of what CHP is and what it provides. So it would be interesting to see how flexibility and efficiency go hand in hand because in industry as ours, we struggle to see it as something that is a viable investment. For example, if you were to invest, you cover all your energy needs with the CHP and then you are maybe mandated to invest in electric boilers. But if we already cover the energy need with the CHP, electric boilers are just there to sort of act as a solution to the renewable penetration into the system that is sort of now being overdeveloped. So we need to find solutions that sort of work for industry more than just forcing industries to go into technologies that may not work for them. So yeah, this is my take.
That's a fantastic point, and we have 3 industrial users with us today, and obviously flexibility is, and I've been told this many times or reminded many times that most industries have already utilized the very small margin of flexibility that is already available, so they already optimized as much as possible. So maybe in the future, maybe in the paper and pulp industry, there is some possibility for flexibility, maybe through thermal storage. We had a small discussion about that in the previous panel. But of course, we see flexibility more being applied from a district heating perspective, especially at lower temperature heats. And that's why it's a natural segue to you, Andre, and your perspectives in terms of district heating and the results of the study, especially the 2 use cases in Romania and in Poland when it comes to district heating. So we would be happy to hear from you.
Thank you, Hans, for the invite and the possibility to attend this panel. So I had a look at the study, which we received a couple of days ahead of today. And I think it contributes to the important effort of highlighting the benefits of CHP from a more, let's say, detailed perspective. From our sector perspective as district heating and cooling, CHP is still widely underestimated. So it's like the sleeping giant of the energy transition. Many are not aware of its benefits. CHP in district heating often saves approximately 50% of carbon emissions in fuel on the heating side if compared to decentralized gas boilers, which are very prevalent in most countries as a heating system. So 50% plus is actually the 2030 goal. And we had this in 2022 thanks to CHP. And I believe this message can't be repeated often enough because many industries, also the DHT sector, especially in Germany, but also in other countries, relies heavily on this technology and actually probably developed because of this technology, because in the past, when decarbonization wasn't an issue, the efficiency gains of using the unavoidable waste heat of thermal power generation was one of the main benefits of this technology to essentially decrease prices for heating. So that would be my first point, that the study is very helpful to highlight the benefits of district heat of CHP in a very detailed way. The second part is that it underscores the fact that CHP is not competing with electrification, but actually complementing it, because obviously electrification draws from the system, but who is producing it when we need it, right? So there need to be some flexible power generation in the system. For now, it's often natural gas-fired plants. In some European countries, it's still coal-fired plants. If they were condensing plants, that would be a huge waste of fuel and essentially emissions. So CHP is actually here helping to balance electrification, especially in connection with thermal storage. And that means it has a strong synergy with the large heat pumps. In Germany, we have a strong growth of the large heat pump sector in the district heating area, which is very nice to see. But we also see companies that combine CHP and large heat pumps successfully to essentially provide grid balancing services to the electricity net. One more important point, I think, from a reliability and resilience perspective is that CHP provides is proven and reliable. It's been there for many years. The technology is sophisticated. It's mature. There's no or very little unexpected risk involved in deploying it. So that is one more important point. And I think what we should not forget that CHP also has an important role in district heating, at least from my perspective, in beyond the transition, even if we get towards almost completely decarbonized electricity system and heating system, it can operate with low carbon fuels, essentially using them most efficiently. It can make geothermal heat much more economically viable, as seen in Germany in some examples. So this study that you presented today, I think it helps the effort to increase the visibility and understanding of CHP, which are critical for its support. It's not just a transition technology, it's a system enabler for the current decarbonization and also for the future climate neutral energy system. As a bottom line, I would say CHP combined with electrification and heat storage is a pragmatic, cost-effective bridge to deep decarbonization in the district heating and cooling sector, especially during the transition phase, but also beyond. And from a pragmatic point of view, since this is already all deployed, there are best case examples that many can learn from to implement working solutions quite easily. Thank you.
Thank you, Andre. And then now turning to the European Commission, DG Energy, Eric, we welcome your very initial reactions to the results of the study.
Yes, indeed. I'm in DG Energy in the unit dealing with research, innovation, competitiveness, and digitalization. And in particular, I'm coordinating the set plan, so Strategic Energy Technology Plan Working Group on industry, meaning sustainable and efficient energy use in industry, meaning energy-intensive industries mainly. And indeed, I've been busy with this working group. Probably it has to do that because I was for 19 years in industry, working as engineer, so I know your concerns and how industries are operating. 4 years ago, also, I became grandfather, and I realized then that my granddaughter would be 77 in 2100. So the motivation to hand over a planet that is in good health is really driving my motivation every day. And the EU is at the forefront of climate mitigation and CO2 emission reduction. But of course, it cannot do it alone. It represents 7% of the emissions. And so it has to be a bright example that the other regions, other continents want to follow. So meaning that it has to be successful economically, and the industry has to be very vivid also. But indeed, especially in view of the latest crisis and the rising prices of fossil fuel, we definitely also have to reduce our fossil fuel imports, be less dependent on that, and so use homegrown renewables and low carbon like nuclear. But of course, renewables are variable, so we need flexibility. And then indeed, flexibility can be at various levels, at supply side, at use side, and also in between with storage. And CHP indeed can play a role both in supply and use side, and in a very efficient manner. I also hear that it can be progressively, well, depending on the availability of decarbonized gases, running more and more on a renewable or methane or biomethane. So indeed, I heard the contributions from industry, and I would very much agree that I am very open to any technology, and on a case-by-case basis, CHP can be a more efficient solution, but other solutions, indeed, like industrial heat pumps, e-boilers, thermal storage combined with thermal storage can also produce heat while having a flexible use of electricity, so and taking advantage of low electricity price. Of course, I see a specific advantage for CHP that the energy is produced on site, so less need to upgrade grid connections, and that's definitely a problem that's not to be neglected. And so operating the CHP flexibly to reduce use of the CHP when the electricity is low cost, while using it more when the prices are high, and even reinjecting electricity into the grid is certainly a decisive advantage. And of course, with the Electricity Market Directive, we are incentivizing the countries and the system operators to open the flexibility markets to also reflect in the dynamic price of electricity, to including to industrial users, to give the right signals for operating the systems, probably with even more flexibility than today, because if the tariffs are more flexible, if there is a bigger range between high and low prices for industry and also for the grid fees, this will be an even strong incentive to use the CHP flexibly. And also, the digitalization of the grids to convey also the data about energy, to aggregate the information from the whole system and generate also the right price signals is also a file on which we are working. So. As you know, I didn't have so much time to discover the results of the study, as there was some mishap in the distribution to me by email. Maybe I lost the email, but I will read it with interest. The first hints that were shared by the colleague from Compass Lexecon seem very solid and strong. So welcoming this study and the analysis that shows that CHP has a role to play, not only transition, but for still decades and decades to go. Thank you very much. Yeah.
Thank you. And you alluded to the fact that you're managing a working group within the set plan. So if interested, we're more than welcome to present the high-level results to the wider working group as an opportunity to share the results further. Maybe turning back to the ceramics industry, and Magda, you mentioned, okay, electricity consumption has gone down 7%, I think that's what you said, and that's not, you said 7%, okay. 7% has gone down, but that's not because of increase efficiencies. It's just that the market is shrinking a little bit. But when it comes to the current energy crisis, and we've gone from energy crisis to energy crisis, the invasion of Ukraine, and now the situation in the Middle East, it once again highlights the EU's vulnerabilities around energy dependencies and infrastructure constraints, especially when it comes to energy price volatility. In your view, given these various different crises, does cogeneration still fit in the context of the ceramics industry?
Well, absolutely, yes. I think the study shows exactly that point. We need to increase the resilience of the system, and basically it is a way to do it. If we think about also gradual electrification, that's also an element that we need to take into account. We probably cannot decarbonize from one day to the other. So not only from technological point of view, but also from cost perspective, and the crisis has shown that this basically the framework we are in needs to be much more flexible. It also needs to be reflective to the different economic cycles, because right now well, we have the world's highest and strictest regulations and the highest prices on both energy and carbon markets. So basically, there needs to be more responsiveness to this kind of situations and crisis. And yes, even if we just think about the carbon costs that also are correlated with the energy costs that we are already paying very high in Europe, especially as energy-intensive industries, there are a large share of our production costs. This needs to be reflected in the setup. So the cogeneration there, I see there's definitely the role that we already mentioned for the energy security, especially if we continue on the electrification pathway, yes.
Thank you. Maybe going to Germany, Jan. I mean, Germany is one of the countries that has consistently recognized and promoted cogeneration as a key solution, both in industry and in the case of the paper industry, but also in district heating. There's even a dedicated CHP law, and many member states look to Germany in jealousy and has supported and provided targeted support. But has the German framework been adequate in supporting CHPs, especially today and looking into the future when it comes to the paper industry? And what do you think is necessary moving forward from a policy perspective as part of Germany's Endegewinde process moving forward from a national perspective?
Yeah, first of all, you're quite right. The German government was for years now really into supplying the CHP use in the industry, especially also in the pulp and paper sector. But to do so, there was a special aid scheme, of course. And if it comes to aid, you always have to talk to the EU Commission, and this also includes, of course, DG Competition. And there might have been a little bit of disagreement about some topics. So obviously, we have to find a solution for that so that we can go on with supporting CHP. But if we take a look on the broader way and an outlook to the future, then Germany is about to install a capacity mechanism, and I think this is something where CHP as the most efficient possibility to provide long-term baseload energy can prove itself just through the technology, not through any other aid scheme. So the more we go into the future, the more we have to take a look on the capacity mechanism, and I think we will see CHP being there very active in this scheme. And the second question was, what are the barriers so far? And I think one big barrier is in our minds that we think energy efficiency on the site level is the most important thing, and we now have to get things in a broader perspective. Maybe the on-site efficiency needs to take a backseat for the overall efficiency, because in the end, transformation is all about integrating renewable energies that needs flexibility, and flexibility normally leads to lower on-site efficiency for the CHP plant, if you just take a single look on that. But if you take everything together, the production of renewable energy and then the flexible solution with CHP, then it's much more efficient. And so when it comes to concrete legislation where it says CHP has to have a certain amount of efficiency, then we should maybe overthink that if you can use the CHP to integrate renewables, because if you don't, then in the end we can't have a flexible CHP, then you can't integrate renewables, and then the overall goal might be not achieved. So maybe we should go back with so specific regulations and try to take a focus on the broader look, for example, the overall CO2 emissions or something like that, because that's in the end what we want. We want to reduce the fossil emissions, and maybe we should focus on that.
Thank you, Jan. Turning to Laura, Metlen is a key EU player in both the aluminum production and also in the energy market. And as you mentioned, CHP is at the core of your company's activities, supporting energy security, decarbonization efforts, but also, as important, if not most, competitiveness. You follow the policy debate here in Brussels in terms of industrial decarbonization closely, which is linked to electrification, flexibility, and also a shift towards renewable energy. How does your company approach these strategic options moving forward? And do you still see CHP as part of the company's future?
Yeah, absolutely. I mean, CHP, as I mentioned at the beginning, is the core of our business and the way we operate. What we need to remember is that CHP is there primarily to deliver energy efficiency. So for us, this is still the most efficient, cost-efficient and cost-competitive solution we have that currently is the most effective as well because it runs on gas for us. So because we use gas, for example, in our CHP, it allows us to have the lowest carbon alumina in the world. So because gas is still the most sustainable fuel that we have, that is available also at scale, and for the high temperature heat that we need for alumina. We don't see really renewable fuels in our industry. Of course, for others it's different, but in our industry we don't see it viable in the next few years or in the foreseeable future, let's say. Until, of course, this is developed at scale that is needed, and also to be able to supply with this stable, continuous heat. You mentioned also, our study at the beginning. Yes, we did a similar study. Of course, CHP flexibility is different than primary aluminum flexibility that we were trying to see with this study, where we sort of went into the industrial consumption of electricity. But the outcomes of our study and yours are sort of similar in the sense that most consumers, most industrial consumers need around-the-clock electricity, but the same thing applies to heat. So interrupting what our study showed, interrupting this production that is around the clock and operating and using a lot of electricity because primary aluminum is completely electrified process. We've seen that interruptions, for example, for up to 1 hour of shutting down your production can amount to cost of several hundreds of euros per megawatt hour. So this is quite difficult. On CHP flexibility, of course, it's a bit different, but the cost is sort of similar because, as I mentioned at the beginning, we would have to invest. For us, maybe a solution could be electric boilers. But again, if we cover all our energy needs with a CHP already and we use it the most efficient way possible, so for heat and power as well, investing in electric boilers, there is no business case there for us because it requires us to invest double the capex. But we definitely see CHP as something for the future, of course. And I think we need to sort of hammer the point home when it comes to also the energy efficiency directive that's coming up, the revision that is coming up, of energy efficiency. Because if you operate CHP flexibly, if we shut it down, it's not designed for our production to ramp it back, up and down. So we lose efficiency. We could probably lose the qualification for high efficiency cogeneration because that requires you to have 10% of primary energy savings. But we see that with flexibility, it would be hard to achieve that status, for example. So we sort of need to rethink what we really, for district heating and cooling, of course, this is different for lower temperatures. But when you come to the higher temperatures, we don't want to find ourselves in a situation where we are sort of mandated to, for example, to be able to operate the CHP to to integrate electric boilers, even though it's less efficient, often leading to more costs and just lacking a business case. So this is a part of, definitely CHP is going to continue to be a part of our operations.
Thank you for that. Thank you for the support and point taken about flexibility. Andre, I'm going to take two questions and sort of combine them in one. So you coordinate the IEA District Heating and Cooling Collaborative, which gathers member states and energy experts from around the world. It's not just Europe. How do you see the results of the study relevant for the future of district heating in Europe, but also other geographies? I'm quite curious to hear from you, especially outside of the EU and those member states' approach to decarbonization, as well as energy security of supply, but also flexibility when it comes to district heating.
Yeah, thank you very much for the interesting question. So, in essence, the study results underline our current very pro CHP position as a group. So they're not, obviously not all countries are very pro CHP, especially the Nordic countries who have cheap electricity, have obviously less CHP than other countries that are more fuel dependent. But for example, if you look at the US, CHP often provides very hands-on resilience after hurricanes, etc. The campuses that have CHP units are still running where everything else is dark. In China, CHP allows to heat, the most cities. And while they use a lot of coal, burning the coal in boilers, which they've done before, is much less efficient and carbon friendly. So even coal-based energy system like China saves carbon emissions directly by using CHP. And the most interesting part is the huge savings in resource exergy, which is similar to primary energy, like it's the next level primary energy metric because it considers the different temperatures accurately. So we have over 650 terawatt hours of this exergy saved, which is really a huge amount. I know that was in 2022. So what I can say is, from the global perspective, CHP plays a huge role in the district heating sector and is essentially the backbone of the carbon reductions that it provides so far to the world and has provided for a long time. Unfortunately, this is not always understood because the evaluation methods do not all hold up to scientific scrutiny. I'm thinking of the Finnish allocation method that is sometimes used in the EU, which distorts the picture if you look at it from a scientific point of view. So from my perspective, it would be very helpful to have really accurate evaluation of efficiency. We just heard from Mettelin also that we need efficiency in the system. We heard from the German, from Jan Schaffenbach, that we need a very overall view of the whole system. And I'm sorry, I mispronounced the name. It was Schafrath, obviously. So I apologize for that. So in general, district heating and cooling is very much dependent on CHP so far. It has reaped a lot of benefits. Not all countries are fully on board yet. Some countries I know consistently under-evaluate CHP as a technology. I'm thinking of a neighbor of Germany that I'm not mentioning that has a low amount of CHP and does not yet fully reap the benefits of it. But, for example, our Canadian friends are looking into connecting nuclear condensing power plants to district heating grids and understand that this could be a way to heat their cities efficiently without the need of overloading or over-engineering the electrical grid. So yeah, what I can say, district heating sees CHP as one of the core technologies. In the past, we were called district heating and CHP. We shortened the name a bit. to not focus only on CHP because now it's part of a big, broader solution, but it will be a key part in our view and in the world for the years to come.
Thank you, Andre. And looking at the questions that are coming in through the Q&A function on Zoom, there was a question actually about nuclear CHP, and you touched upon it. I mean, there are different applications of SMRs, AMRs, and microreactors, and district heating is one possibility as well when it comes to that. But there are other applications such as industrial as well, which we can get into later as well. Maybe turning to Eric, and speaking of the EU set plan, you have several working groups that are focusing on energy efficiency in industry, but also buildings and on renewable heating and cooling. How could these discussions with the set plan focus more on energy system integration and technology synergies versus individual technologies in silo? And maybe a good example of maybe not the best way to do it is the recent announcement that we heard from your Director General about including the heating and cooling strategy in the electrification action plan instead of the other way around, but maybe that's too politically incorrect.
So definitely the system approach, whether you put one communication into the one or the other way around, is questionable indeed. In the end, the important thing is that maybe they are regrouped in a single document, so that indeed the system aspect are tackled. And yes, also listening to the interventions of the colleagues, I hear about the opportunity cost of flexibility of several hundreds of euros per megawatt hour in industry, and that was also reflected in previous studies from Smart 10 in specific sectors. So it's good that the industry communicates to the Commission. I'm an engineer. I was in industry for years, for decades even. 2 decades, so this is something I feel intuitively as an engineer, but that is not obvious in the communication in the Commission. So don't hesitate to communicate on why is this opportunity cost so high, because first it may be seen as, oh, you switch off your system, you restart a few hours later when the electricity is cheaper. And that's it. Why don't you do it? Seems to be so easy. So definitely, and also talking about the loss of efficiency when you modulate the power, either in the process itself, where indeed losing heat during those hours, losing products maybe, is very big consequences. But for me, would be also a question of maybe softer modulation when you modulate your CHP maybe minus 20% or plus 20% to, in that case, maybe the efficiency loss is not so big.
Or slightly tweaking the definition of high efficiency CHP, maybe looking at it at an annual basis.
Yes, maybe also introducing a bit of a factor, taking into account the flexibility. Mm-hmm. Yeah.
Okay. Thank you. Maybe noting that we have around 10 minutes left as part of this session, open the floor to questions from the audience. Realizing that the energy levels are a bit low and everyone is perhaps thinking about the networking reception, we still have some work to be done before we can enjoy the fruits of our efforts. So any questions from the audience? Everyone's so shy. Okay, well, maybe just looking to the Q&A function. There was a question that we discussed in the last panel, and that was like, yeah, taking into account the gas prices that we're facing today and possibly still increasing, is it still efficient to invest in these types of energy capabilities, i.e. gas-based CHP, even if they are smaller and localized and distributed power generation.
No? Okay, perfect, thank you. I mean, for gas specifically, we still see it in industry, of course, as the most reliable fuel we have to operate at these high temperatures, as I said before. It's hard to see a viable solution there, but it's still something that is investable. So it's still, no matter the high gas prices, it's still something with regard to how the market works and the core of our business as well, you know, with integrated alumina and aluminum production. It's still something that we see as providing us this continuous, provides us to and enables us to continue operations around the clock, which we need to then supply, to then refine the alumina and then to feed into the aluminum plant as well. So for us, renewable fuels, as I mentioned, it's something that will be explored in the future, but for now it's not a viable option. And electrification as well is not always the way forward in all industries. Because again, it's not just gas prices that are high, it's electricity prices that are high. And for energy-intensive industries, electricity prices, especially for our primary aluminum production that's fully electrified, is the biggest barrier basically to sort of scale up industry. But when we talk about dependencies that we were talking before as well, I mean, of course, we are seeing a lot of impacts from the crisis in Iran and from the COVID crisis back then. We've had 2 energy crises in less than a few years, which is a huge problem. But something that definitely should be explored is how to, what you mentioned, homegrown renewables, but also how can we also source some other fuels here in Europe? What can we do with domestic production as well? To reduce further these dependencies, because, you know, it is said that we just switch dependencies to US with LNG. So how can we not just switch dependencies, but how can we ensure that we don't have them in the end? I mean, this ties into fuels, but it ties into critical raw materials, it ties into all industry in general. What I wanted to also mention, because I think I didn't have the chance before, but one thing that if we are looking at the energy market and if we are looking at CHP, one thing that definitely is impacting its business case is the ETS heat and fuel benchmarks. So I'm pretty sure everyone is familiar with that. But we are now facing this further tightening, very aggressive tightening that is going to end up penalizing industries that are already sort of operating and using the technologies that are the most efficient, like CHP. So this is something definitely that we see as overall needing also fixing, and for CHP also to continue to have a business case overall. But yeah.
I'm sure our member state leaders' ears are burning because they're probably discussing this very issue now in Cyprus as part of the European summit. But you mentioned volumes and alternate fuels. I mean, I wanted to point out that the European Biogas Association published a similar report just yesterday, looking at the potential for biomethane and e-methane production potentials up to 2050. And on the low side, they're talking about 181 BCM compared to today, which is around 22 BCM. And then on the high end, we're talking about 205 BCM by 2050. So obviously, there is potentials for other sustainable fuel productions other than just natural gas. And so, of course, and this was mentioned in the previous panel, I mean, using CHP and using these valuable resources in the most efficient way possible is a no-brainer, you would think.
Can I go back to the question as well, just to react? So, of course, we are also concerned with the tightening of the benchmarks, just to be clear. But I wanted to take a bit broader step back, because what I heard today also at another panel is that, in fact, we are now in Europe facing a moment where the level of investments in general is the lowest ever. So this is just to give a perspective. But I wanted to make a positive note because, in fact, cogeneration, for us, it is a mature technology. So for us, it is a safe bad. So for that, I wouldn't be worried. It's just until now, it always helped us, you know, to look to achieve efficiency, savings, and so on. But if in the future it also can help us decarbonize in a cost efficient way, that's of course very welcome.
Okay. If there are no questions, any last remarks from Jan or Eric?
Maybe after my colleagues both mentioned the benchmarks, I have to do that too.
I'm afraid Eric's from the wrong DG, but
yeah, that's why I promised myself I don't want to talk about that, but I can't be the only one left on the stage from industry not mentioning it. But I think we are now heading for the really overall question of the transformation itself, and do we really want to achieve it or not? And it's not about how often you say you want to achieve it or how good or nice your target is. It's the basic question, are you willing to fund it? And that's a question until today we didn't really had to ask ourselves that, because within the very good mechanism of the ETS, the combination of a CO2 price with free allocation is, I think there's no better system than this combination. We had the possibility to relocate the money within the industry and within the sectors, but now we are coming to a point where there is no money to relocate, and now we have to find other funding sources. And so far we didn't really have a solution for that, and that's why we're still talking about, which is crazy, about cutting more free allocation, which is basically cutting the base of the industry. And so yeah, I think now we will see if do we really want to achieve the targets we made, and the only answer to this is do we get the funding for that or don't we do that? And then in the end, of course, companies can invest, of course, also in cogeneration, because as you said, it's a very safe bet, no matter in what direction you want. As long as you want industry in Europe, then cogeneration is a very good bet.
Thank you. Eric, any final remarks, comments, observations?
Well, about the use of biomethane, so the non-fossil gas. Definitely, I see that the use in CHP, especially for generating high temperature heat in industry, is really the best way to use that gas. So because of the very high combined efficiency of electricity and gas on one side, and heat on one side, and also because it's providing heat at high temperatures, so preserving the exergy that was mentioned before. So even more interesting to use CHP in industry, I would say, than for district heating, where the temperature delivered in heat networks, urban heat networks, is of course much lower.
Or heavy trucking in Germany. And then Andre, any final remarks from your side?
Yeah, thank you for mentioning exergy. It's pleasant to hear that this is moving forward, this concept. I think I agree that high temperature continuous uses of CHP are obviously a very good use case. However, I also believe that in district heating, we still have this temperature level of 100, 130 degrees, which is very hard to go down from unless major investments into the pipe networks are funded. Usually CHP has the big advantage that it becomes more efficient on the electrical side the lower the temperature on the thermal side. So if we compare overall efficiencies in terms of exergy, it's pretty similar, unless you take out, and flexibility obviously is always quite expensive because you have the ramp up, ramp down, you're not in the optimal point of operation. So I think the study that COGEN Europe presented today is a good example of how we all can learn more about what is a really good solution from a scientific perspective, because in the end, the climate doesn't care what we think, right? It does care what we do. So if we do the right things and we identify them by thinking like scientifically, and we combine all our knowledge, including the study that we've seen and presented today, I think we can go towards a future that maximizes cost-benefit ratio and benefits everybody in the end. And CHP will definitely play a role for at least one, probably 2 or more decades to come, from my perspective, in all sectors mentioned. Thank you.
Thank you, Andre. And this is a good point to pause and recognize our panelists in person and online. So thank you for their contributions. So put your hands together and your virtual hands together. And thank our panelists for their insight, their valuable contribution, and their support as well of the study. And I think one of the takeaways from both panels is taking what we've been saying for quite a long time, but actually quantifying that and providing empirical evidence why CHP makes sense in certain contexts and how CHP can continue to work in the future in a more hybridized fashion, working in a system integration and working in tandem with other technologies and being fuel flexible and providing that energy security and competitiveness to allow industry to continue to operate in Europe, as well as continuing to provide that heat energy security when it comes from a cogeneration perspective. So thank you again. Thank you to our panelists. You may sit down and I will try to wrap things up and conclude. Actually, I don't generally prepare remarks, remarks in general, but closing remarks. But I felt, given the importance of the study and the discussions we had today, I wanted to be as succinct as possible. So let me give it a go. So as we come to close today's event, I first of all want to sincerely thank all of you for joining us both in person and online. And for contributing to such an insightful discussion on the future of Europe's energy system, not just about CHP, but how CHP has a role to play in the wider energy system, may it be from an industrial perspective or may it from a district heating perspective. So we've seen that today's exchanges have once again confirmed that Europe's energy transition is not only about reaching climate targets, it's also about ensuring competitiveness, and that was highlighted in the second panel for sure, but also resilience, affordability, and security of supply. I think this is particularly important for Europe's energy-intensive industries while facing rising global competition, while being asked to decarbonize rapidly at the same time. But I think it's equally important for district heating systems when it comes to consumers expecting affordable heat, security of supply as well, and a clear pathway towards climate neutrality. These challenges require practical solutions that can deliver now while supporting the longer-term transformation of our energy system. So at COGEN Europe, we strongly believe, obviously, that cogeneration has an important role to play in this future energy system, not in the decades to come, but in the foreseeable future. For industry, it can provide reliable heat and power while enabling gradual electrification. When it comes to district heating, it can support flexibility and help integrate renewable thermal resources. And for the wider electrical or electricity system, it can contribute to dispatchable capacity and balancing services, as we heard today, when they're most needed. So in short, cogeneration is not just a technology of the past, it's a solution that can evolve alongside Europe's decarbonization pathway and work in partnership with other clean energy technologies. I would like to thank Compass Lexecon, Gerald and David, for their excellent work in producing this important study for us and for our members, but also to all our speakers and participants who shared their expertise throughout today's program. Finally, I would like to offer a special thank you to the sponsors. I don't know if we have a slide that we can share of this study and of today's event. Their support and commitment made this initiative possible, and we're grateful for their continued dedication to advancing efficient, resilient, and sustainable energy solutions in Europe. I also want to thank the team that's never seen, and that's the technical team in the back from the Wright Street Company. So thank you for making this possible and for bringing this to our participants online as well. And also a special thanks to the Secretariat, to the staff, to Alexandra, to Chiara in the back, Dominica and Tanya, who are not seen but are preparing the reception, so you'll see them later. So special thanks to them and their dedication and their work over the last year getting this study to fruition and to publication. But before I close, let me highlight that today's launch is just the beginning of a conversation. In the coming months, we are planning a series of additional webinars under the banner of the COGEN Europe Power and Heat Boost brand, each focusing in greater detail on one of the 5 use cases presented in today's study, while also featuring other additional use cases and practical experiences from across our wider memberships. There's an opportunity to learn more. In addition, I should point out a separate use case dedicated to data centers. We hear a lot about it, we talk a lot about it. There's a lot of excitement in the cogeneration sector, especially for my colleagues in the US and globally as well. But there's obviously an interesting use case or justification for using CHP in different configurations for data centers. So this is also, data centers in general are an increasingly important sector for Europe's competitiveness. We heard about digitalization, but also energy resilience. And we hope to have this published before the summer break, so look out for that. So please stay engaged with COGEN Europe as we continue to bring forward practical solutions and evidence-based discussions for Europe's energy future. So, ladies and gentlemen, thank you once again for being with us today. We look forward to contributing to this dialogue together, hand in hand, and working with all of you to build a cleaner, stronger, and more competitive energy future. So thank you, enjoy the evening, and cheers.